As we talked about early on in the semester, when we're looking at doing a comparison between two or more groups, looking at two different groups, if we're going to look at more than two, remember we said that the student t-test would be appropriate to use for the two groups, and for two or more groups, it would be the analysis of variation, which is also known as ANOVA. What ANOVA seeks to do is to determine how much of the variation in the data sets can be attributed to error and how much can be attributed to the factor or treatment that's under study. So once again, we had kind of talked before about, early on in the semester, about a tobacco cessation study. And if you would be doing this study and the individuals would be participating in it, and then you would do follow-up to see, how many people actually quit smoking or quit using tobacco. Well, there's still going to be that risk of error because you don't know if these individuals have gone to another tobacco cessation treatment plan, or whether or not they maybe have read stuff, maybe they have got stuff from the state or their dentist or their doctor's office. So there could be some sort of a variable in there that would cause them to quit smoking, and it would absolutely alter how successful your program was. The ANOVA test looks at the source of variation in the overall data set and then tries to basically divide or distribute. A portion means to divide or to distribute it to different aspects of the data. So what we're looking at is going to be what could have caused that variation in the data set. Was it actually our treatment, or was it something else that caused that variation? Once the variation's been allocated, it is then possible to see where the differences between the sample groups are actually showing significance. So basically all that's saying is that once we can determine why there's a variation in our data sets or in our groups, then we can determine from that point on, if we've determined what the variation is, then we can rule that out. Then we can actually look if there has been a significance in our tests that we have done between, once again, three or more groups. So all we're saying here is that once we determine what that variation is and why our data sets aren't similar, which of course we want them to be somewhat similar, but and once we determine what that added reason is that they're not similar, then we can go back in and we can look at our actual study and look at, is this a study that has provided us with some significant or statistically significant results? The sources of variation in the data basically are the variabilities that occur within a sample group and the variability that occurs between the groups that we're talking about. So I kind of italicized the within and between because think of your groups, and you'll see I put a little diagram in coming up. Think of having three groups, and then each one of those groups having a variation in the data, and then those three groups having a variation between the three groups. So within the one group, you're going to have a variation within, the sample size, within the individuals or the participants in that particular group. And each one of those groups are looked at separately, but then you also look at them kind of together. So between the groups, we're going to look at the variation as well. Now, once again, I always like to stress to you, I want you to understand the concept of how you would use an ANOVA, when you would use an ANOVA, and what it actually is going to show you. I don't want you to get caught up thinking that actually I kind of think the book, that's why I did my own PowerPoints for this. I think the book is a little bit, or quite a bit actually, more in depth than what we really wanted to go into for this this section on testing three or more groups. So don't get caught up in actually the statistics part of it as much as I want you to understand the concepts and when you're going to use it. Once you go into research methods, you will have a much better idea as to how to use these concepts in research methods. So looking at this little diagram that I put together, you're looking at three different groups. You're looking at fitness levels of group 1, fitness levels of group 2, and fitness levels of group 3. And then all the arrows are showing is that between all three of those groups, there's going to be variability. Okay, that's all that's showing you. It's obviously the groups are separate, and you're going to see differences, but there's changes, there's variability in all three of those groups. So from that previous slide, we can say that variability between the groups plus the variability within the groups is going to equal out to be our total variability. And that's what ANOVA is going to do for us. Once you would apply that in, say, SPSS to whatever your study is, you're going to be looking at, once again, variability between and within the groups, and that's going to give us the total variability that we're going to find out with our testing. We are interested in the between group variation. That's what I said before. For example, with the example that I used with the fitness level, that's occurred in between those groups. The rest of the variation that's within the groups we regard as error. Okay, so looking at each group, separately, when we see variation within those groups, we regard that as the error. Okay, so then once we look at each group individually and we find that error, then we can discard that, and then we can actually look at what we're studying and to see if there is actually any statistical significance to our results after we've gotten rid of that error. The variability between groups will reflect the error that occurs within the groups, and any additional variability is caused by the treatment. In this case, it would be the fitness level. If there is no difference between the groups, then the null hypothesis is correct. Remember, we talked about that. If it's something that is not statistically significant, then we're going to say that we adopt the null hypothesis. Then we would expect there to be just as much variation between the groups as there is within the groups. So all that pretty much saying is if there's no difference between the groups, then we would just kind of, I don't want to use the word assume because you really don't want to assume, but understand that there's probably just as much variation between the groups as there is within the groups. So there is no difference. Looking at your three groups, if there's no difference, then we can pretty much assume that that's going to be the same for each group. If the between group variation is more than the within group variation, then we know that the treatment has had an effect. And this is the simple logic behind the ANOVA test. So all that's saying is that if between group variation is more than within the group variation, then we know that we have had an effect somewhere. That's all that's saying. Once you put the statistics into the actual program, like I said, that the program will do that for you. But that's all we're looking for. We're trying to find out, using the ANOVA, 3 or more groups, 3 or more study groups, and all we're looking for is variation from within the groups and outside of the groups. So we're just looking at a total variation. So once again, if between group variation is more than within group, so visualize that, then it's simply said that the treatment has had an effect. Just some concepts for you to understand when to use a one-way ANOVA. You're comparing the difference between 2 or more sample groups. Remember we said that. That's like a really big thing that you need to know, because when you're looking at data or you're looking at a study and you see, when you're reading, you're going to see what test of statistical significance that they actually used. You're going to know that if you're looking at something, so just some concepts that you need to know when to use the ANOVA. Obviously, I think I've drilled it into your head that it's, when we are looking at 2 groups, we're going to be using the student t-test or the t-test. When you're looking at 2 or more sample groups, you're going to use the ANOVA. The data in each of your groups is normally distributed, so it needs normal distribution, so you're not going to have some, crazy outliers within that group. It should be normally distributed. Your data should be data that is measured on the interval scale, and each case is measured independently. So you are going to be looking at each individual person or each individual that you have in that study group. Each person or each participant, I should say, is looked at independently. And the one thing that you'll always read in association with using an ANOVA, we say that the individual cases must be independent. And all we're looking at with independence is that there should be no way the measurements taken from one individual or object can interfere or be affected by those taken from another individual or object within the study. An example of independence, if you were issuing a questionnaire to 2 or more groups of people, and it was possible that the 2 groups could talk to each other and discuss the questions, clearly the samples wouldn't be independent then. They would definitely, there would be a definite risk for instability within that test.